Welcome to the Deep Dive. Today we're tackling, well, maybe the biggest head-scratcher in modern science, the quantum reality problem. I mean, for ages now, physicists have the math down, right? Yeah. But they just can't seem to agree on what it actually means for reality.
It's a huge knot, yeah. And for this deep dive, we're going to try and cut through it using a really fascinating source. Excerpts from The Quantum Enigma, Finding the Hidden Key by Wolfgang Smith. He's a former professor of mathematics, UCLA, MIT. Quite the background.
Smith is definitely an interesting character, known for some very heavy-duty math publications, but also really focused on, exposing what he sees as philosophical assumptions that science just adopted without realizing it. Scientism, he calls it.
Right. And our mission today really is to pull out this single hidden key that Smith talks about. He basically argues that all the confusion around quantum mechanics, measurement, wave function collapse, all that weirdness, it only persists because we're hanging on to this one really old philosophical idea without even knowing it.
Okay, so what's the big culprit? What's this assumption we need to ditch?
Smith lays it out pretty clearly. He says, the problem isn't the physics itself, it's the philosophy underneath. The real fallacy, the thing propping up pretty much every interpretation of quantum reality so far, is what he calls residual Cartesianism, from Galileo and Descartes. And he claims, pretty boldly, that the second you let go of that assumption, quantum theory suddenly makes sense.
Residual Cartesianism. Okay,
Yeah.
let's unpack that, because if it's unconscious, we need to drag it out into the open first, right? We're talking about the famous split, the Cartesian partition, bifurcation.
Exactly that. Descartes, he basically chopped reality into two completely separate boxes. You've got res extensa, the world of extended stuff, the external world defined only by things you can measure: size, quantity, motion, position, and space.
The stuff mathematical physics can really sink its teeth into.
Precisely. Then, in the other box, you have res cogitans's thinking things, the mind, basically. And everything qualitative got shoved in there. Feelings, consciousness, and crucially, all our sense perceptions: color, sound, taste, all relegated to this internal, supposedly non-physical realm.
Seemed neat for building classical physics, maybe, but what was the hidden cost, philosophically speaking?
Well, the cost was massive. Smith calls it an epistemological impasse. Think about it. If you say qualities like color only exist in the mind, res cogitans, then the red apple you see out there, well, it can't actually be read in the external world. It becomes just a sort of mental image, a phantasm.
Oh, wow.
Yeah, it made the external world perfectly quantifiable, perfectly mathematical, but impossible to actually perceive directly. It throws the reality of the whole external world into doubt, doesn't it?
It kind of creates this universe that's like perfectly understandable with equations, but totally fake to our actual experience.
And Smith argues this whole split is just artificial. It's reductionist. He insists qualities like color and quantities like mass are both objective properties. They belong to the object, and they're both contextual, depending on how you interact with the object or the conditions. Take redness. It's an invariant, he says. A red thing, looked at by someone with normal vision in white light, will appear red every time. It's an objective feature of its corporeal existence.
That sounds like a huge tension, especially for scientists day to day. They're constantly using their senses, observing things, but the underlying philosophy says those senses are basically lying to them about reality.
He calls it a collective state of schizophrenia. I mean, the whole point of this split, this bifurcation, was to push towards a totalist physics, this dream of explaining everything just with quantities, no messy qualities left over. But to do that, the scientist ends up in this weird spot, philosophically denying the reality of the very thing they were looking at: the pointer on the dial, the track in the bubble chamber, the corporeal evidence they rely on.
Okay, that sets things up perfectly. So if this Cartesian view is the mistake, the way out must involve bringing back what was lost. Smith does this by defining two distinct levels of reality.
Exactly. We need to really grasp the difference between what he calls the corporeal world, X, and the physical universe, SX.
Let's start with X, the corporeal world. That sounds like the normal world.
It's the world we know directly, through our senses, yeah. But crucially, it's the realm of actuality. Things in X are definite, they're perceptible, they're fully realized. And we perceive this world not just with raw senses, but with what Smith terms intellect.
Intellect, hang on. Why intellect? Is that different from just reason or mind?
That's a really key distinction Smith makes. He's using intellect in a more traditional way, not just analytical reason, but a kind of intuitive, direct seeing. It's the faculty that grasps the thing itself, its qualities, the redness, the hardness. Reason, in contrast, is what breaks things down, analyses, abstracts into math. X is known directly by the intellect. It's a direct perception of actual reality.
Got it. Direct knowing of actual stuff. So how does the physical universe, SX, fit in?
SX is different. It's the realm of things we can only know indirectly through complex measurement and theoretical models. It's a world made up purely of quantities and mathematical structure. Think of it like this. X is the red billiard ball you can see and touch. SX is its theoretical description, maybe a cloud of atoms, or an idealized sphere defined by variables like radius r and density delta, things you can't actually perceive.
Okay, so we have these two worlds, X and SX. They're in the same place, right? Spatial coincidence, you said. But they're fundamentally different kinds of reality. How do they connect? How does information get from SX to X if they're separate ontological planes?
Right, they don't just magically jump. The absolutely critical link, the one Smith says we've ignored, is presentation. X, the corporeal world, is the presentation of SX, the physical universe. The qualitative reality we experience, X, is how the purely quantitative physical reality, SX, shows itself, how it manifests to us.
Can you give an example, like that bubble chamber photo on the book cover you mentioned? How does that work with X and SX?
Sure. So when the physicist looks at that photo and sees the track of the omega minus particle, that visible track, that's an event in the corporeal world X. It's actual, perceptible. But how did it get there? It happened because the unperceivable physical object, the particle itself, existing in SX, interacted with a special kind of medium. Smith calls this a subcorporeal instrument, SI.
Subcorporeal. What makes an instrument subcorporeal?
Think of a normal measuring device, like a thermometer. We look at the pointer, right? We read it directly. That's an interaction within X. A subcorporeal instrument, like the superheated liquid in the bubble chamber, operates below the level of actuality. It's kind of latent. The physical particle, SX, zips through the liquid, SI, and the effect of that interaction, the trail of bubbles, gets amplified or transmitted up to the corporeal level where we can actually see it. The SI acts as this bridge, forcing the potential SX to present an actual result.
Ah, okay. So that distinction between X, the actual world we live in and experience, and SX, this underlying world of potential, of measured quantities, that's the big shift we need to make.
Yeah.
And once we really accept SX isn't just a fuzzy version of X, but something fundamentally different, then the quantum weirdness starts to make sense.
That's the claim. Exactly. If X is the realm of actuality, then what about the quantum microworld, the world of atoms, electrons, photons, the stuff that makes up SX? What ontological category does that belong to?
Well, it can't be actuality, can it? Because
Yeah.
quantum mechanics says it's indeterminate before measurement.
Precisely. So drawing on Aristotle, actually, and Heisenberg, too, Smith argues that the physical universe, SX, exists in the ontological category of potentiae, possibilities. An electron, before you measure it, isn't a tiny definite ball at a definite place. It exists as a superposition of eigenstates, basically, a combination of all the possible states it could actualize into. It's pure potential.
So the infamous quantum uncertainty isn't because we're clumsy measurers. It's fundamental. The system is indeterminate. It's potential waiting to become actual.
Yes. And that realization, according to Smith, solves the central mystery: state vector collapse.
Right. The sudden, discontinuous jump when a measurement happens.
Yeah.
The thing nobody could explain.
Smith says the collapse is simply that ontological transition we've been talking about. It's the shift from potentia, the indeterminate superposition of possibilities in SX, to actuality, the single, definite, observed outcome in the corporeal world, X.
That seems to elegantly handle things like Schrodinger's cat, doesn't it?
Mhm.
The whole paradox comes from trying to treat the cat, which is obviously an actual corporeal thing, as if it could exist in a quantum superposition.
Exactly. Smith points out the cat collapses its own state vector just by being a cat. By existing on the corporeal plane, X, it is actual, therefore it is determinate. The transition isn't caused by someone peeking in the box, some psychic act. It's an ontological requirement of moving from the potential realm, the poison mechanism, to the actual realm, the living or dead cat.
Okay, but if the collapse is this transition from potential SX to actual X, then the huge question is what causes it. Physics normally talks about cause and effect happening over time, right? Like one event leading to the next. Horizontal causality. Why doesn't that work here?
Because horizontal causality operates within the actualized world, UX. Billiard ball, hitting billiard ball, that works for processes unfolding in time among actual things. But the transition from a non-actual potential state, SX, into the realm of actuality, X itself, that's different. That's bringing something into being, in a sense. It's a creative step. A realm of pure possibilities can't just decide on its own to become one specific actuality. It needs an impulse from, well, outside of that temporal sequence.
Okay, so creating a specific fact from a cloud of possibilities needs something else, a non-temporal cause, a transcendent cause, and Smith calls this vertical causality.
Yes. Or sometimes naturans, the naturing nature, the principle of creation itself. He sees it as the agency that provides the determination, that selects one outcome from the potentiae and makes it actual. It lifts the system from potentiality into actuality.
Now that's a big step. For someone listening with a purely scientific mindset, they might hear that and think, hold on, isn't that just smuggling God or metaphysics in through the back door to plug a hole in the physics?
That's a really important challenge to address. Smith's argument isn't meant as like a proof for God disguised as physics. It's presented as an ontological requirement. The argument is the quantum math only describes possibilities. SX. We observe actual facts, X. Therefore, logically, something must bridge that gap between potentiality and actuality. That bridge, that act of determination, must be non-temporal and creative in nature, whatever name you want to give it. The physics itself demands it once you accept the SXX distinction.
And how does all the randomness and probability we see in quantum mechanics fit into this? It's not just any outcome.
Right.
There are strict probability rules.
Right. Smith connects this to concepts like the yin-yang polarity. You have determination, the specific outcome, but you also have indeterminacy, the field of possibilities. He sees the indeterminacy as the yin aspect, the necessary leeway or freedom within the system. The system has to obey the probability laws. It's the yang, the necessity, the mathematical rigor. But the actual moment of collapse, the selection of which possibility becomes actual, that's where the freedom, the vertical causal act, comes in.
So it's this amazing blend of freedom and necessity, as he puts it. The rules are fixed, but the specific outcome is chosen, moment by moment, from the potentials.
Precisely. And the whole framework really stands or falls on accepting that the corporeal world we experience, qualitative, actual, is fundamentally distinct from the physical universe of potentialities described by physics. The real hidden key isn't buried in more equations. It's about shedding that old Cartesian way of thinking that flattened reality into just quantitative stuff. It's about recovering a richer ontology.
And this leads to a pretty mind-blowing final thought about what a physicist is actually doing when they make a measurement. If every measurement involves this vertical causality, this non-temporal creative act, what does that imply?
It implies that every single time a quantum measurement happens, it's what Smith calls a cosmogenetic act. The physicist isn't just a passive observer watching reality unfold. They are, whether they know it or not, participating in the ongoing non-temporal act of creation itself. It's not something that just happened hypothetically at the Big Bang. It's happening right here, right now, every time potentiality is resolved into actuality through observation or interaction. The physicist is, in a sense, picking up the creative act.